And if you wanted to figure out what the voltage was across each one of them, you could now, because you know the C value for each one, and you know the Q value for each one, so you could figure out what delta V was across each of those three capacitors. But we weren't asked for that. We were just asking for Q. You okay with this? The reason is, right, as you start to move charges around, this battery, when we first hook it up, starts to move some charges. And so I'm going to draw them in red. A positive charge, if you like to think of positive charges moving, goes over there, or if you like to think of the negative charge, actually goes the other way, and it leaves a positive behind, right? They can't move. And you move a couple of more. So those go through the battery, right? But there's an open circuit here. They can't go any further. But there are electrostatic interactions, or electric interactions. So these positives over here are going to attract some electrons. So some electrons, I'll do these in blue. Some electrons get attracted to this side. And that's going to leave some positives behind over here. And these red electrons over here are going to repel some electrons. They're going to end up over here as far away as they can get. And that's going to leave some positives over here. So whatever charge, if this is plus Q and this is minus Q, then all this is going to be minus Q, and that's going to be plus Q, and this is going to be minus Q, and that's going to be plus Q. They are all going to have the same value. Because it's the ones internal here, all the blue ones, those are just charges redistributing. The battery only really moves the red charges. So they all end up with the same Q. And why is that Q total? Why isn't it 3Q for Q total? Because what happens if you take the battery out and you stick a light bulb there? How many charges go through the light bulb and make the light bulb light up? Only the red ones do. The blue ones just go back, redistribute back where they were. They don't go through the light bulb. So the total charge stored is just little q. That's what went through the battery. Everything else just moved around internally here. And if we were to hook this up to something to try to get the charge to move through it, to get some energy out of it, all we'd get is the little q. All we'd get is the red ones, and the blue ones would just redistribute internally. We wouldn't get anything out from those. So the total charge is equal to the charge on any one of those capacitors when they're in series. But in parallel, it's just like making the plates. We've tied the plate here to the plate here to the plate here. We've made the plates bigger. We've made this one big capacitor by hooking them up. So if we hook up, if I do the same trick with the red charges, the red ones, we get positives building up on this side. And negatives on that side. If I take the battery out and stick a light bulb there, all of these red charges go through the light bulb and make it light up. We get them all out at the end. That's why we add them up. Okay, capacitors in series and parallel. All right, that wraps up today. Have a good weekend.